to skim water. You have flying submarines.
Sea skimmer.
Sea skimmer.
Had many engines.
A lot of engines.
8 plus 6, 14 engines.
Flying submarines, which didn't pan out.
Flying submarines. Didn't work, huh? Ooh, what's this? Wreck.
That type aircraft. Yeah.
Oh, this one up here hanging?
The back end. The back end.
Oh, wow.
And then seawater. You see what seawater does to aluminum.
Yeah, aluminum.
The fastest air-breathing airplane in the world. They will admit that it could fly faster than Mach 3, fly higher than 80,000 feet. How much higher? How much faster? The last one of its type to fly for the Air Force flew from the west coast of the United States to the east coast in 68 minutes and 17 seconds.
Wow.
And that included a refueling operation over Texas where they had to go below Mach. Something going through the air that fast is going to generate air friction, and it does. Typically, outside the cockpit, skin temperature in the vicinity of 600 degrees Fahrenheit. You can bake a cake at 350. Around the engines, 1,000 degrees Fahrenheit. So obviously, you cannot use aluminum magnesium. It would melt at those temperatures. They had to find a material to stand that heat, and they did. Called titanium. Titanium, lighter than aluminum, stronger than steel, has a very high melting point. So 98% of what you're looking at is titanium. That's a lot of golf clubs. Artificial knees, artificial hips, even cookware is made of titanium. Very expensive, but it's naturally grease resistant. These other things like Teflon, that's coating. But titanium is naturally grease resistant. Almost kept the airplane from being built. Because as an airplane is being put together, you have engineers walking around with a grease spritzer. Drill here, cut here. Wouldn't work on titanium. Grease wouldn't take. But they found out felt tip can work. So the airplane got built. The fuselage generated the lift. And they had some models that didn't have any wings at all. So they used some of that technology in designing the shape of the airplane. Those little wings couldn't provide enough lift. The fuselage provides the large majority of the lift. And then the engine. Found that below Mach 1.1, a normal turbojet engine was efficient. But above Mach 1.1, a ramjet was more efficient. So when they built this airplane, the engines are composite. Below Mach 1.1, there's a normal turbojet engine. Above Mach 1.1, they converted into a ramjet engine. Those cones come out and divert the air around the basic engine. Then the speed of the airplane compresses the air. They don't need that compressor section, which is drag. So the speed of the airplane compresses the air, puts it in the afterburner section, and fuel is injected in there. Now we've got a ramjet engine. Some of the air still goes into the basic engine to provide basic services like electrical and hydraulic and things like that. But the main thrust for the airplane is a ramjet engine. A Mach a Tier 3 bar, you just call one of them a sled driver. But I guess he got used to it because he put a book out later called Sled Driving. And some comments in it, in fact, the whole book is just amusing anecdotes. And the first one that I like, that you have never really been lost until you've been lost at Mach 3. air-to-ground attack section. That's where I spent my whole career, throwing my body at the ground. There's an attack helicopter here, Huey Cobra, on the nose. See those two windows on the nose? One is low light level TV, and the other is forward-looking infrared.
Any TV in there?
Pardon me?
TV in there?
Yes.
Wow.
And it detects targets in low light level conditions, like starlight, moonlight. On the other side, it detects target by the infrared radiation coming from its engine, like a tank engine or a truck engine or something. And the gunner will zero in and fire a missile.
8 of them.
Well, this one is equipped with what they call tow missile. Tube launched, optically tracked, wire-guided missile. When the missile is fired, a very fine copper wire spools out of the back end of the missile, and the control signals come through that wire, and the gunner controls the missile into the target.
So it's self-guided? It's a guided...
It's guided by the gunner. And the signals come through that copper wire. After the first Gulf War, there was so much copper wire spread around the sands of the rocks that you couldn't even drive on it. All those everybody had tow missiles. Jeeps had tow missiles. Tanks had them. Helicopters had. Everybody had tow missiles. So there was copper wire all over the place. The later versions of attack helicopters are using Hellfire missiles, which are self-guided, homing type. Now, the reason the gunner sits in the front seat and the pilot sits in the back seat, because the gunner is the one that controls the missile. On the chin of this helicopter, there's two tubes, see down there? Those are 40 millimeter grenade launchers, and they're for anti-personnel attack. Fired a solid projectile. Towards the end of the war, the Navy converted to 20 millimeter, and it started a controversy between the Air Force and the Navy as to which is best, 50 caliber or 20 millimeter. The Air Force says 50 caliber could fire a lot more bullets than the 20 millimeter. But the Navy said, yeah, you hit them with a 50 caliber, you're going to make a half-inch hole. You hit them with a 20 millimeter explosive round, you're going to make a hole. And that continued through the Korean War, and towards the end of the Korean War, Air Force came over to 20 millimeter. Then they come up against technology. They wanted to get more and more rounds out per minute. But the machinery they had at that time was physically not capable of it. The 20 millimeter had what's called a breech block. See, a 50 caliber had a bolt that went back and forth like that. The 20 millimeter had the breech block that would load and lock. At a high rate of fire, this breech block sometimes got halfway, and would sit there doing this. It's called a breech block float. The gun was useless. And at a high rate of fire, you would have sometimes 2 or 3 bullets going down the barrel at the same time. When each bullet hit at the end of the barrel, it would cause the barrel to flip. And that decreased the accuracy. You start thinking, how are we going to increase the accuracy and rate of fire for the 20 millimeter? And that's when General Electric came out with their Vulcan Gatling gun. Because only one barrel is firing at a time. It eliminated barrel whip and extra accuracy. And rotating at a high rate of speed, you get a high rate of fire. Normally, only the 3 o'clock barrel fires.